Hey guys, what's up? My name is Gabe and this is Games with Gabe, and this is the next episode in the Coding a 2D Game Engine in Java series. So in the last episode what we did was we got picking working correctly, so now you can go around and click on any object and it will switch to whichever object you clicked on and then bring up its properties in the properties panel. This is great, but we need a way so that we can actually start building levels. So in this episode we will be implementing a camera. And this camera will also support smooth movements, and it will also support recentering back to the origin of your scene just in case you get lost. So if you go somewhere way out here and your zoom is way messed up, you can always just go back to the center of your scene, or eventually when we have a properties panel over here showing all the game objects, you can click on one of those and center on the game object, which will also be really cool. But by far, the most exciting thing is this smooth movement. So we'll take a look at how all this works in this episode. So let's get started. Before we get started, as always, we are going to look at how this will work in theory, and then we will actually code this. So how do we get the camera to move in the opposite direction to which we drag our mouse? And how do we get it to do that smoothly? Now, this is actually a little bit difficult to get the first try. I always have to mess around and setting the settings properly, like sensitivity and everything. That is by far the hardest part. But let's say that the user clicks here, and this is where they start the drag. So this is the original click position. Then they drag their mouse this way. Now in my mind, when somebody drags the mouse this way, they want to move the camera this way. You can set it up differently if you would like, but this is how we will be doing it for this tutorial. So they click the mouse, they drag it this way. Now, how do we know what distance to move the camera? What we want to do is we want to figure out what the distance between these 2 points are. Then we want to move the camera so that it moves in a proportional distance this way, because we would expect it to move proportionally to how we moved the mouse. So what we need is we need the original mouse position, and then we need this position, which is the position, and this would be in the next frame too. So this is all happening within a frame. So I'm exaggerating the distances. The distances in actuality are going to be very, very small, but that is in essence what's happening each frame. So we get that new position. And now this is literally just simple vector addition, subtraction, right? So if we have this and we have this point, then getting the distance between those 2 points is literally as simple as saying this minus this. So to get that distance, we'll just call that delta. It's just equal to pose minus original. All right, so now we have that distance, but we don't want to just jump the camera from here to here immediately. I mean, you could if it's a frame, but if you get a big lag spike or something, it's going to glitch and then it's going to seem like it's jumping. So it just won't look that good. So instead what we'll do is we will interpolate this. So linear interpolation, also known as Lerp, is literally just saying if you have some start and some end value, so that's your start and that's your end, and you have some delta time that you want to apply this over, so some time variable, then you can interpolate this so that it gets applied evenly across the time. So in our case, delta time would be our time variable, right? The time between the last frame. Our start would be this original position. Our end would be this position that we want to get to. And so what we do is we say, okay, just multiply. So we'll add part of this distance times whatever time we currently have. So delta time may be here. And so when we multiply delta time, we will end up here. And then what we'll say is we'll say add this distance, which will get us to somewhere like right there. And then we do this again the next frame. And then we move original to this new position. So then we say, okay, now original equals this. So that the next time we do it, we'll move right here. And then it will smoothly move across until we get to the next point. However, there's one extra thing that you want to think about, and that is for the other scenario I showed you where the camera's like way over here, but you want to move it all the way back to the center. And so to get it to move smoothly and then speed up as it gets to the end so that we don't get this weird situation, because if you keep doing this, you'll notice that what ends up happening is it actually, as you get closer to it, it never fully reaches it. And so you just get slower and slower and slower, and then you get this problem. And I'll show you that too once we actually start coding this. But to avoid that, what you can do is you can increase delta time for each time step you take. So we can say, okay, so for each frame that we move, will actually increase the steps delta time is taking. That way we get to the end quicker. So you would just say something like delta time equals 0.1 plus equals 0.1 times delta time. And so what this does is basically for every time step that we take, we're adding on a little bit extra bit of time so that the next step we're taking is bigger, which means we will get closer to E faster. Okay, that may make sense, that may not make sense. One last thing that we're going to talk about is zooming. So if you're zooming out and you're zooming in, it can be hard to make it zoom out and zoom in a speedy way. And what I mean by that is if you're taking the same step of zooming out each time, you're going to actually have to take a larger step, because when you zoom out once and say you zoom out by a portion of like 0.1, that's going to zoom you out a pretty good distance. But then if you're already zoomed out to like a 10x zoom level, so you're way out, and then you just go 0.1, that's going to be a relatively small step. And so you're going to have to scroll a ton just to get it to keep zooming out. And so one way to combat this is to zoom out faster the farther out you get. Well, how do you make something go faster the farther out? And we can use, once again, just mathematics and use a exponential function, right? Because an exponential function looks like this. So when you get really close, it starts going slower, 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 slower. When you get really far, it gets bigger, 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 bigger. And so if we use this exponential function to curve our zoom level, then as our zoom level is at 10x, and we say, okay, now we want to go 0.1. Well, 0.1's here. Well, actually, that's a pretty big gap. Whereas if we're here, which is like 1, and we take 0.1, the rise is relatively small. So even though we're taking the same step, we'll actually be taking bigger y steps each time. So we'll use an exponential function to ensure that we get a nice, fast, and even zoom. And I'll let you know the settings I used, just so that you guys can get some good settings with yours. All right, let's take a look at the code. I am back in our project here, and as you can see, this is the same place we left off. You can click on the objects and change them, and it just switches to whatever object you click on, which shows us that our picking is working. So first step, let's go and add a new component, and we're going to call this our editor camera. And the reason I'm calling it editor camera is because this is going to be different than a regular camera component. And so we're going to want to make sure that is clear for like game cameras. And we'll have game cameras pretty soon too, because I think that'd be pretty cool to do. It's going to require a bit of work, but it'll definitely be a cool thing. So how does an editor camera work? Well, first of all, we need to make sure that we extend component, because we are just going to be using this as a component, easiest way to get it into our sort of system. So then we'll just say public void update will override that method so that we can use this. And we will create a constructor for our editor camera. And we're going to say that this constructor actually takes in a camera, and this is going to be the level editor camera. So just nice to pass it in, and then I'm going to hit Alt Enter, and then create field for parameter, then just hit OK. And there we go. So that created that real quick. And then we're going to need that other variable I mentioned too, private vector to f click origin. So where did they click on when they initially clicked? So we'll say this.click origin equals a new vector to f. And then inside of our update method, we will have to do quite a few things. So first of all, we have to detect if we are dragging the mouse or not. And normally I would say we could just use the mouse listener's is dragging method, but it's not working properly and I haven't looked into fixing it yet. So we will fix this in a future tutorial, and then we will switch this up to use that. Instead, what we'll do is we'll just use a simple debounce. So what we'll say is private float drag debounce, and we'll set this to a small number like 0.1. So this means after 0.1 seconds, the drag will initiate. So it'll be like, oh, we're dragging, which is usually fine. Nobody will notice that 0.1 second delay. So then we'll say if mouse listener dot is dot mouse button down, and then we'll say glfw mouse button middle. You can change this, of course, to whatever you like. I just think that the mouse button middle is good. And then just make sure to import that. And we will say drag debounce is greater than 0. Then we'll say this.click origin equals new vector to f. And we'll say mouse listener dot get ortho x mouse listener.get ortho y. So we get the mouse position in world coordinates because we want to make sure that we are doing everything in world coordinates. That way we get an appropriate like movement distance according to what the user would expect when they're looking at it. So then we'll say drag dbounce minus equals dt, and then we will just return. So this way we just get a click origin that is appropriate, and then we will make sure to decrement dt until we're outside of this dbounce. And let's actually make this dbounce 2 frames. So if we're running at 60 FPS, that means we're running at 16 milliseconds. So that would be 0.016 seconds. So then we'll just say 0.032, which should be 2 frames. So if they are holding it down for 2 frames, we'll assume it's a drag. Then we'll say else if mouse listener dot mouse button down, GLFW mouse button middle. We can assume that the drag dbounce is now less than 0 because otherwise we would have entered this one. So if we're in here, then we'll say vector 2f mouse distance, or delta. I'll call this delta because that's why I called it in our drawing, is a new vector 2f. Once again, mouse listener to get ortho x and mouse listener dot get ortho y. Then we want to make sure to subtract, I'll move this to a new line, dot sub, the original click pose. So click origin. Okay, and all this is going to do is it's going to get that delta value that we talked about, the delta value between when we first clicked and where we are in the next frame. Then we will simply say level editor camera dot position dot sub delta dot multiply by dt, and we'll need something else there too, but for now this will be fine. And then like I said, we're going to lerp the original click position, so that way we get like a smooth movement. So then we'll say this dot click origin dot lerp new vector 2f, and we want to get where the mouse is right now. So that would be mouse listener. Well, let's actually just cache that as another variable, make that a little bit easier. So we'll say vector 2f mouse pose equals new vector 2f, and then we'll say mouse listener dot get ortho x and mouse listener dot get ortho y. Then we can just switch this to use mouse pose, move this back up, and then we can just say mouse pose, and we want to lerp it by delta time. So this sort of gives us that smooth movement. It'll just reset the click origin, then lerp it, and then we will continue dragging and continue lerping. So that's more of a smooth movement. It's not very jerky if you're sporadically moving the mouse. Now you could do this other ways. This was just the best way that I found, and it sort of made it work the best for me. So now if we go back into our scene and we click our mouse button, nothing happens. Surprise, surprise. That's because we have to go into our level editor scene first and actually add this component. So we'll just go up to level editor stuff, and we'll say add a new component, editor camera, this dot camera, and we have to make sure that the camera is created. I did not when I first did this, and that messed it up. So let's move this up to the top so that we actually have a camera to pass into our editor camera. Now if we run this, okay, so if we move the mouse, first of all, it's like moving the wrong way, but you'll notice it's smooth movement, and it's definitely like a smoothing of whatever the mouse is doing, but it's not going the way I want it to, and so we can fix that pretty easily. Okay, and so the only reason that that was not working correctly is because the sensitivity was very low. So if you just add in a variable called drag sensitivity, I set it to 30, and then as long as you mark it up here, we multiply the delta times dt times the drag sensitivity. Now, when we go back in, you'll notice that this moves pretty much directly in response to wherever the mouse is going. And it's kind of jerky, and that's because we never reset our dbounce. So we just want to make sure that we reset the dbounce too. So we'll say if drag dbounce is less than or equal to 0.0f, and not mouse listener dot mouse button down, GLFW mouse button middle. So if the middle mouse button is not down and our drag dbounce is less than 0, then the dragging has stopped. So then we can say drag dbounce equals 0.1f, reset that, and we should be good. So now if we go back in, we should get rid of some of that jerkiness for when we restart a drag. Yep, and sure enough, now you can click and drag, and it all works pretty good. All right, cool. So now we have dragging done. Now we want to make sure that we get zoom done. So let's add in the zoom factor. And like I said, in order to get that to work, we will just use a exponential function to make sure that it zooms appropriately. So we'll say if mouse listener.getScrollY does not equal 0.0f. So if they are actually scrolling, then we'll say float add value equals float math.power. So this is the same as an exponential, and we will use the base as the scroll. So we'll say math.absolute value of mouse listener.getScrollY. So that will be sort of our base. And then we want to raise it to the power of 1 over the level editor camera.getZoom, which we do not have yet. So let's move this to a new line first of all. And then let's actually create a zoom level for our camera. So if we go into the camera object, then we will add in another variable up here. We'll just call this private float zoom equals 1. So 1 is like your 1-to-1 ratio. So this is no zoom. And then so on and so forth as you go up and down. And actually, let's just go up to here, say Alt-Enter, create getter and setter. And then we will also go down here and say public void add zoom, and then float value. Then we'll just say this.zoom plus equals value. So we have all these functions that we can use, but it's not actually going to zoom our anything out right now. And so the way we get it to actually zoom is we just modify the projection according to the zoom. So we'll say just multiply the projection size by the zoom, and that will make sure that we actually zoom out and zoom in as you would expect. Okay, so then if we go back into here, this should be good now. We do 1 over the camera editor.getZoom because that makes sure we have an exponential function that works inversely proportional to the camera's actual zoom level. And then we can say add value times equals math.signNum of mouse listener.getScrollY. And what this does is this basically says if they're zooming out, make sure you get the sign, which is a negative, and then zoom out. And then if they're zooming in, make sure you get the sign of that. And we should actually make this a negative so that it zooms the correct direction. And then we'll just say level editor camera to add zoom and our add value. So if we do this now and we zoom, nothing happens. Why does nothing happen? That's because we have to go into the IMGUI layer and make sure that it knows that we want to pass in the zoom as well. So we have this GLFW set scroll back right here. And inside here, we're just going to say mouse listener.scroll callback. And then we will pass in W, X offset, Y offset. So we'll just pass everything in. We may modify this in the future because this will actually zoom regardless of where the mouse is. So, oh, nope, the zoom still isn't doing anything. So we have to figure out what's going on with that real quick. Okay, and so the reason that it's not actually zooming is because I forgot to actually adjust the projection matrix. So if we go back into camera, you'll notice that we actually have to call this function in order to apply that new zoom, which is never being called. And so the easiest way to get this to work is just to go into level editor scene, and then we'll just say this.camera.adjust projection, which should adjust the projection. So now if we go into here, we zoom out, we zoom in, you'll notice it goes, but it never stops. And that is because we have to go into our window, and then right at the end of the frame, we just have to make sure that we call mouse listener.end frame. So we go into here one more time, and if we do this, there we go. So you'll notice we're zooming, it's just taking very big steps, which is not good, and the grid is messed up, which we will also have to fix. So in order to get it to take even steps, we just need to add a sensitivity to this. So we just want to make sure that we add a sensitivity here. So we'll say multiply it by scroll sensitivity, which will just basically make sure that we can control how fast that we are zooming. So I'll just go ahead and add this right below our drag sensitivity. So we'll say private float scroll sensitivity, and I think I set this to 0.1. Yes, so 0.1. Let's run this one more time, see what happens. Okay, so now the zoom is working better, and you'll notice it slows down as we go farther in, and it speeds up as we get farther out, which is nice. And if we move around, it moves around, except our grid lines are messed up. So let's fix those up real quick. It's relatively simple. We can look into here and notice immediately that we're just not taking into account the camera zoom in the projection size. So what we can do is we can just say camera equals window.getScene.camera. And then we will just replace all this stuff too with camera, because there's no reason to have them calling the functions. Okay, and then we can go into here, and as long as we multiply this by camera.getZoom, that should fix the problem we were seeing. And then camera.getZoom, just to make sure we get the appropriate amount of vertical and horizontal lines. So if we go into here one more time, zoom out, almost working. We just have to make sure to also put it inside of here as well. So then we'll say camera.getZoom, and then we will multiply this guy by camera.getZoom as well. And run this one more time. Now we should be good. Okay, there we go. So now you'll notice that the grid expands as we expand the zoom, and we get all this. But now what happens if you're like way out here, then you zoom in, then you move around a little bit more, you're lost, right? And you don't really know. Well, we know it's right here, but what if you do get lost for real? How do you get back to the center? And we're gonna add in a hotkey so that it just moves the camera back to the center in the original zoom, which is nice to have just in case you ever get lost in your scene. And so we can add that by just going back into editor camera, and we will just add in a reset value. So let's go up to here, and we'll say private Boolean reset equals false. And so if reset is set, then we want to reset the scene. So then we'll just say if key listener dot is key pressed, and then I'm going to say GLFW key keypad decimal, which is the same hotkey in Blender that is used to center on an object. So that's just the decimal key on your keypad. You could set it to whatever key you want. And I'm just going to say reset equals true. Then we'll go down here and we'll say if reset. The reason we do it this way too is because this will happen over multiple frames. And so we just want to make sure that we have a flag instead. Then we will smoothly move the camera by using the lerp function once again. So we will linear interpolate. So we'll say level editor camera dot position dot lerp, and we want to lerp to 0, 0, which is just the place we want to go. And I would say DT, but we'll see why this will not actually work very well in a minute. And then down here, we're just basically going to say if it gets relatively close, then clamp it. So if math.absolute value of level editor camera dot position dot x is less than or equal to 5, and the reason I chose 5 is just because that's what worked best. Level editor camera dot position dot y is less than or equal to 5, and I'll move this to a new line. And we will do the zoom in just a minute, so we'll just focus on position for now. So we'll actually leave off that final and. So then if it's pretty close, then we'll just say level editor camera dot position dot set 0, 0. That way we were there exactly, and then we'll just say reset equals false. So we just sort of clamp it there if we get close enough. Now let's run this and see what happens, because there's a problem with this, and it's the problem I mentioned before. So if I hit dot, you'll notice it moves, and it just keeps moving. It's still moving. It's still moving. So it sort of just very slowly settles in, and we don't want that. So the way we can fix this, I looked up on Unity's website to see how they fix it, and we'll use the same method, which is basically that whole adding a fraction of dt to our increment so that it speeds up as it gets closer. So we'll say private float lerp time, which is just sort of our flag, and we initialize that to 0. And then down here, we will say lerp using lerp time. And then after we lerp, then we will say this dot lerp time plus equals 0.1f times dt. So we just sort of add a portion of dt to the lerp time so that it gets bigger every time that increment gets better. Then when we reset it, we'll just say this dot lerp time equals 0. Now if we do this and run it one more time, you'll notice that it just sort of clamps into, it goes faster, and then it clamps into place way quicker, which is nice. So this is good, much better. The one thing we don't have though is the zoom. So if we move, it moves us back to the center, but we would like it to move the zoom as well. So we'll just manually, there is no lerp function for a float, so we'll just manually lerp it ourselves. And the way we can do that is we can just say level editor camera dot set zoom, and then we want to just sort of add. Actually, let's just click into here, and you can take a look. They just say plus equals other x minus this x times t, which is your delta time. So we'll do the same thing. We'll just say plus equals 1, which is the value we want it to go to, minus the current zoom times t. So we'll go into here, and we'll say we're going to set the zoom to the level editor camera dot get zoom plus, and then I'm going to move this to a new line, 1.0f, and let's actually do this, minus, sorry, level editor camera dot get zoom. So 1 minus other x times lerp time. So we do plus equals 1, which is other x minus this x times delta time. Cool. And that should do that automatically for us. And then we'll just add in the zoom. Actually, we'll not even add the zoom check into here. We'll just say this dot level editor camera dot set zoom to 1. So once we clamp, we get to the right position, we'll just make sure to clamp the zoom as well. And so if we go down here, we zoom out, then you'll notice it all works perfectly. Cool. So if you hit your hotkey, which mine is numpad 0, but if you have something else and you're like way zoomed in and you just want to get back to the center, you can just hit that hotkey and it'll take you there with everything sorted out perfectly. All right, so that is it for this tutorial. I hope you guys enjoyed it. You'll notice that this does hit a limit. So if you zoom out too far, it doesn't work quite so good. And we can fix that in a future date. You can literally just hit a zoom max level so that you can zoom out. Also, I want you guys to help me solve this. So if I click an object, the farther away I get from the origin, you'll notice the more that this object is not lined up with the mouse. And then once I get back close to the origin, it's lined up. I'm not sure why it's doing that. I haven't had time to look into this, but if you guys want to look into this and let me know if you find out why that is and how we can fix it, that would be awesome. So leave a comment below telling me how to fix this if you find it out. But anyways, I hope you guys enjoyed this. If you did, please hit like and subscribe, and I'll see you in the next tutorial, which will probably be adding more to the properties panel. So we can actually do more with the properties, because right now you click on it and it really doesn't do anything, which it would be cool to have a little bit more here. We can change the picture and everything like that. So yeah, we'll work on that. Anyways, I'll see you guys then. Thanks.